Every civilization begins small. It uses the energy available on its planet, burns fuel, builds technology, and slowly increases its consumption. On Earth, all our technology exists thanks to energy supplied by the sun. Even fossil fuels are actually ancient solar energy locked in matter. But imagine a civilization that does not stop at planetary scale. As technology advances, energy demand grows exponentially. A sufficiently advanced species would eventually face a simple limitation. Its planet cannot provide enough power. At that point, the only logical step is to go directly to the source. Instead of living under the light of a star, such a civilization might attempt to surround it. This idea was first seriously discussed by the physicist Freeman Dyson in 1960. He suggested that an advanced civilization might build a vast structure around its star to capture most or all of its energy output. This hypothetical megastructure became known as the Dyson sphere. What a Dyson sphere really is. Despite popular imagination, a Dyson sphere is not necessarily a solid shell enclosing a star. A rigid shell would be mechanically unstable and almost impossible to maintain. The more realistic concept is a Dyson swarm. This would consist of millions or even billions of satellites orbiting the star in coordinated paths, each collecting solar energy and transmitting it elsewhere. Over time, more and more collectors would be added until a large fraction of the star's light is intercepted. From a distance, the star would appear dimmer in visible light because much of its radiation would be absorbed. However, energy cannot simply disappear. According to physics, absorbed energy must be re-emitted, typically as heat. That heat would radiate outward in the infrared part of the spectrum. And that is the key. The signature in the darkness. If an alien civilization were building a Dyson swarm around its star, astronomers would not see giant metallic panels directly. They would see something subtler. A star that shines less brightly in visible light than expected. A star that emits far more infrared radiation than a normal star of its type should. In other words, it would look like a star wrapped in a warm, artificial blanket. Astronomers already search for such anomalies. Large sky surveys scan millions of stars, measuring both visible and infrared output. They look for objects that do not fit known natural explanations. Most unusual signals turn out to be dust clouds, young stellar disks, or natural astrophysical processes. But the search continues, because a true Dyson structure would leave a thermodynamic fingerprint that cannot easily be hidden. A strange star in Cygnus. In 2015, astronomers noticed something deeply unusual about a star known as Tabby's star. Located in the constellation Cygnus, this star displayed irregular and dramatic drops in brightness, sometimes blocking more than 20% of its light. No ordinary planet could cause such extreme dimming. Naturally, speculation exploded. Some suggested that fragments of comets or dust clouds were responsible. Others proposed more exotic explanations. For a brief moment, the possibility of a partially constructed Dyson swarm entered public discussion. Further research suggested that dust was the most likely explanation. The infrared signature expected from a large megastructure was not detected at the necessary levels. Yet the event demonstrated something important. Humanity now has the tools to notice when a star behaves strangely. And that means we are capable of detecting large-scale engineering on stellar scales. How advanced would they be? A civilization capable of building a Dyson swarm would be far beyond current human capability. On the Kardashev scale, which measures civilizations by energy usage, humanity is around type 1-. That means we do not yet fully control the energy resources of our own planet. A civilization that captures most of its star's energy would be type 2. Such a civilization would command energy outputs trillions of times greater than our global consumption. With that much energy, they could terraform planets, power interstellar travel, manipulate planetary climates, and perform engineering projects that would look like magic to us. And yet, from across thousands of light years, we might detect them simply by measuring heat. Could they hide? One of the most fascinating questions is whether such a civilization would want to be seen. In theory, a fully enclosed Dyson sphere could capture nearly all visible light from its star, making the system appear dark in optical wavelengths. Only infrared radiation would escape. To distant observers, it might look like a faint, warm object instead of a bright star. However, completely hiding thermodynamic waste heat is almost impossible. The laws of physics require energy to be radiated away. Unless they have discovered physics far beyond current understanding, their existence would leak into space as excess infrared radiation. In other words, even if they tried to remain invisible, the universe itself would betray them. What it would mean for us. If astronomers confirmed the discovery of a true Dyson structure, it would be one of the most important events in human history. It would mean that intelligence is not unique to Earth. It would mean that civilizations can survive long enough to master stellar-scale engineering. It would mean that the universe is not silent because it is empty, but perhaps because it is vast and distant. The discovery would instantly shift humanity's perspective. Every philosophical system, every religion, every theory about life's uniqueness would need to adapt. Because somewhere in the galaxy, someone would have proven that survival on cosmic timescales is possible. The future of humanity. The most unsettling realization is that the Dyson concept is not just about aliens, it is about us. In millions of years, if humanity survives, expands, and avoids self-destruction, energy demand will continue growing. Eventually, planetary resources will not be enough. At that point, the logical step would be to build massive solar collectors in orbit around the sun. Over thousands or millions of years, those collectors could multiply. Gradually, the sun would appear dimmer from afar. Earth would become part of a stellar-scale engineering project. And from across the Milky Way, another civilization might detect the infrared glow and wonder if they are alone. Listening to the stars. Right now, telescopes continuously scan the sky. Space observatories analyze infrared radiation. Data sets containing billions of measurements are searched for anomalies. Most stars behave exactly as physics predicts. But somewhere among them, there may be one that does not. One star that shines too weakly. One system that radiates too much heat. One signature that cannot be explained by dust, gas, or natural stellar evolution, and that would be enough. The ultimate proof. A Dyson sphere would not just be a structure. It would be proof that intelligence can reshape stars. It would demonstrate that life can transcend planetary limits and operate on cosmic scales. And perhaps most importantly, it would show that the universe is not merely a place where stars are born and die. It would be a place where conscious beings can take control of those stars. If such a structure exists, it may already be glowing softly in infrared light somewhere in the Milky Way, waiting to be noticed.